Welcome to Meki Techie. I would like to thank my professor, Dr. Surendran, Government College of Technology, Coimbatore, and I would like to thank my family for the greatest support of doing my YouTube channel, and thank to all my followers and subscribers. Today's topic is brakes. Brakes. What is meant by a brakes? It produces artificial frictional resistance applied to the moving machine member is called as a brakes. There is a two types of brakes available. One is an external brake and another one is an internal brake. External brake, we can say it as an band brake and disc brake are the external brakes. The internal brakes are drum brakes. Here in the brakes, the important thing is equivalent coefficient of friction, that is mu. Mu dash. Mu dash is equal to 4 mu sine theta divided by 2 theta plus sine 2 theta. Here mu is the actual coefficient of friction and 2 theta is the angle of contact of the shoe. The ratio of tension in the band brakes are T1 by T2 is equal to 1 plus mu tan theta divided by 1 minus mu tan theta and whole power n. Shoe width to the wheel diameter ratio is 0.25 to 0.5 and n is the number of blocks, mu is the coefficient of friction between block and the drum, and theta is the semi angle. When we say it as a 2 theta, it is an angle of contact, whereas a theta, it is a semi angle of each block subtending the center of the drum. What are the applications of the brakes? First, brakes used in cars. It is an internal expanding brakes, say drum brake. Whereas in railway trains, the shoe brakes are used. It is an external brake. Okay, what is the material we are using for the brake lining? Material used for the brake lining should have a high coefficient of friction. Okay, what is the value of coefficient of friction here? It is maximum up to 0.4. Okay, next is a very important topic, self-energizing brake. What is meant by a self-energizing brake means when the frictional forces helps to apply the brake, then it is said to be self-energizing. Next, here in the brakes, very important concept is this: the kinetic energy of wheel is converted into heat energy. Yes, we know that energy can neither be created nor be destroyed. It can convert one form of energy into another form of energy. Here, by applying the brakes, the kinetic energy of the wheels can be converted into heat energy. Next, for designing of clutches, for the new clutches and brakes both are similar. We are clubbed together and we discuss. New clutches and brakes. The frictional radius capital R is equal to 1 by 3 times of capital D cube plus small d cube divided by capital D square minus small d square. And for the uniform wear condition of the brakes and clutches, the frictional radius R is equal to capital D plus small d by 4. So the first thing is a uniform pressure theory and the second formula is the uniform wear theory. As per uniform pressure theory, the pressure is constant, whereas the uniform wear theory, the wear is constant. And here uniform wear theory, pressure is inversely proportional to diameter. When the diameter increases, the pressure will get decreases. Like that we are saying. Next, the percentage of total brake effort that result from self-energizing action is depends on. We know that self-energizing brakes are when the frictional force help to apply the brake. It is called as a self-energizing. So the self-energizing is depends on the location of brake arm pivot point and coefficient of friction and direction of rotation of the brake drum. These three are the important factors which the self-energizing brake is depends upon. Next, in order to prevent the brake arm for grabbing the moment of frictional force about the brake arm pivot point, it should be less than the total braking effort required. So this is a condition which we have to know. Okay. So the condition is, in order to prevent brake arm for grabbing the moment of friction force, for taking the friction force about the brake arm pivot point, it should be less than total energy required for braking effort. Next one, block or shoe brakes. In the block or shoe brakes, the tangential braking force is very important. The tangential braking force is directly proportional to mu and Rn. Rn is the reaction and mu is the coefficient of friction. The mu is the constant. It is a proportionality constant here. F of t is directly proportional to R. Therefore, in order to remove the directly proportional symbol, we multiplies coefficient of friction. Therefore, tangential braking force F of t is equal to mu into Rn. Therefore, the braking torque, generally torque is equal to force into perpendicular distance. Here the tangential force into perpendicular distance is nothing but our r, radius. Here we know that F of t is equal to mu into capital Rn. Therefore, the torque required is mu capital Rn into r. When it is a band brake, the ratio of tension is equal to T1 by T2 is equal to e power mu theta, or we can say it as 2.3 log T1 by T2 is equal to mu theta. We are multiplying log in both the sides, we get the second formula. Here the braking force is the difference of the torques, okay, different of the tensions T1 and T2. So therefore F of B is equal to T1 minus T2. Here braking torque, we know that torque is force into perpendicular distance. Here braking force into perpendicular distance. When the maximum tension in the band T1 is equal to sigma T W into T. Here small t is the thickness of the belt and W is the width of the belt. Sigma is the maximum allowable stress in the belt. The width of the band W should not exceed 150 millimeter for drum diameter more than 1 to 100 millimeter for less than 1 meter. Therefore, T is equal to 0.005 times of D. Thank you. Please subscribe and share the content. Thank you.